This is chemistry practical number 3, electrolysis. We will be investigating what happens when aqueous solutions are electrolyzed using inert electrodes. This should be an investigation involving developing a hypothesis. Now, there's a few words in there that I'm going to explain. Inert means unreactive. Now, we don't want our electrodes reacting with the substances we are electrolyzing. Aqueous means that we have a solute which has been dissolved in a solution. And hypothesis. So our hypothesis will be trying to identify what ions are present in the solutions and what will be produced at the cathode and what will be produced at the anode. So before we begin the practical, you should be making predictions. Now, based on the substances we will be using, there are some predictions that we can make. There is a hypothesis that we can make. For example, sodium chloride has sodium and chlorine atoms, so maybe chlorine will be produced. Maybe sodium will be produced. Now, knowing which ones will be positive and negative should inform your decision, but I'll leave that to you. We will be doing the practical, you will be making the prediction. Now, here we have my power pack. You need to be sure not to have it on a very high voltage. We're going to be using 4 volts. Here I have the 4 solutions, my 4 aqueous solutions we will be electrolyzing. I have 2 inert electrodes. We'll be using graphite today, attached to some crocodile clips. And just to stop the electrodes from touching and to free up my hands for testing any gases that may be produced, I've just got a Petri dish with 2 holes in them which fit my electrodes perfectly. And that will free up my hands. Now, it's very, very important that during the practical, you do not let the electrodes touch. Okay, this can cause a spark, which can be dangerous. It will also short circuit the power pack, which again could be dangerous. So very, very careful not to let them touch. Some classes will have used a plastic barrier between them just to stop the electrodes from touching. It will disrupt the flow a little bit in the solution, but safety first, as always. We will do the copper sulfate solution first. So what I would do is I'm going to put my electrolysis guard, we'll call it, on top. The black lead is going to be my cathode. This is negatively charged. My red cable is my anode. This is going to be positively charged. Now, when recording our observations, we'll be looking for signs of a reaction. Are there any new elements formed? Has it changed colour? Are there any bubbles produced? We can then test those gases or use those observations to see what's been produced at each electrode. Now, there are 3 tests we'll be using. There's 3 tests we could be using, should I say. Firstly, oxygen. Now, the test for oxygen would be to relight a splint. Now, because of the amounts of oxygen that could be produced in these solutions, they won't be enough to perform that test. So we're going to be making some assumptions. Hydrogen, that's the squeaky pop test. So it burns with a very loud squeaky pop. Again, the amounts that we will be producing, not enough to produce that test. So we will be making some assumptions. The last one, chlorine. Now, when chlorine gas is produced, it will bleach blue litmus paper a pale white colour. Now, it needs to be damp blue litmus paper. Damp blue litmus paper, bear that in mind. So, I've placed my anode and my cathode in, making sure that they are not touching. Now, be very careful if you are going to be testing for your chlorine gas, that when you move the dish, you don't then knock the electrodes to go and touch. My apparatus set up. Power pack's on 4 volts. So making sure not to let it too run, because if we are producing chlorine gas, it is dangerous and we don't want to be letting off too much chlorine gas. Letting it run. Now, straight away, I can make 2 observations. At the anode, there are bubbles being produced on the anode. On the cathode, there looks to be a change of colour. Now, I'm going to observe what has happened after I've turned it off. So I can see my bubbles being produced there. Just to test for chlorine gas, I'm going to dampen my litmus paper with distilled water. Reach that in there. Testing. And that is a negative result. So that is not chlorine gas being produced. Turn off my power pack. These should be safe to touch. Take those out there. And straight away, you can see that wonderful bronzy brown colour on the cathode. Now, that bronzy brown colour will be copper. Okay? So that was copper sulfate. So let me just put my observations up on the board. So, copper sulfate. My observation at the anode. The anode, we saw bubbles and the product. So we tested for chlorine gas. There was no chlorine gas. Now, one of the assumptions we're going to make is that the bubbles were oxygen. Observation at the cathode, we saw a brown colour, and we are assuming that is copper. So that was the electrolysis of copper sulfate. Next, we're going to move on to copper chloride using 2 fresh electrodes. So I'm just going to put these to the side. So I've set up my 2 fresh electrodes, put my electrolysis plate on top. Just going to move these to the side to try and make them a little bit more stable. Perfect. Again, making sure the electrodes are not touching. I'm going to turn it on briefly. Now, again, at the anode, I can see some bubbles being produced. We'll test that gas. My cathode, you can see, although it is moving around slightly, that bronze colour forming again. Now, we can assume that that bronze colour is copper. That's still in solution. That's fine. Now, I'm going to, again, take my damp litmus paper and I will test the gas coming from the anode. Now, we can just see there's not much chlorine gas being produced, but we can just see it's starting to dye the litmus paper a white colour. If we'd left that for longer and if there was a greater volume of gas produced, that should turn completely white. But we can just start to see the litmus paper turning white there, a positive result for chlorine gas. So, back to the table. The positive anode, we saw bubbles. And the products, we know that's chlorine gas because it bleached our damp litmus paper. So we know this is chlorine. At the cathode, it turned that bronze colour again, so we know that that has produced copper. So brown, and we know that that is copper. Now we're going to get another fresh set of electrodes and we'll test the sodium solutions. Now we're going to electrolyse our sodium chloride solution. 2 fresh electrodes. Oop. Making sure that those 2 electrodes are not touching. I have my damp litmus paper ready just in case. Now, when I turn this on, looking closely, I can see bubbles being formed on the anode, and I can also see bubbles being formed on the cathode. Interesting. Now, we're going to test with our blue litmus paper on both of these gases. Now, quite clearly, I can see here the anode has once again bleached my litmus paper. You can see it just on the tip there, has bleached the tip of the litmus paper a white colour. So that's a positive test for chlorine gas. Now, at the cathode, the bubbles, I'm going to assume are hydrogen. Now, we could test that with the squeaky pop test, but the amount of hydrogen being produced would not be enough. It would also be quite difficult to trap that gas. So, back to the table. My positive anode at the red one, that was a positive test for bubbles of chlorine. The negative cathode has produced bubbles as well. And we are going to assume that those are hydrogen. Now we're going to electrolyse my last solution of sodium sulfate. Again, 2 fresh electrodes. We don't want any contamination affecting our observations, making sure they're not touching. Okay, we'll leave that there. I've got my litmus paper ready just in case. Turning on my power pack. Observations. I can clearly see bubbles being produced at the cathode. I can clearly see bubbles being produced at the anode. I will test both of them again with my damp litmus paper, but I wouldn't be expecting chlorine in a sulfate solution. But just to be thorough, while they're reacting, test the anode. And you can clearly see there's no bleaching on that there. So, turning the power pack off, taking my electrodes out, let's record our final observations. So, the anode, we clearly saw some bubbles. Now, again, with it being a sulfate solution, we're going to assume that's oxygen. The cathode, we saw bubbles again. And we're going to make the assumption that that was hydrogen. So that's a full set of observations and the products that have been formed. My colleague's going to talk a little bit about the reactions happening at the cathode and the anode. We'll talk about some half equations. We'll talk a little bit for the higher paper about why there are gases being produced instead of metals at the cathode.
So my colleagues talked to you about the observations and the products. Now I'm going to try and explain about why, and I'm also going to, for the higher tier, talk about half equations. But before I start, my colleague also wrote panic on the board. That's not because he found this experiment, panicking. It's actually to help us and you remember how you know it's positive for anode and negative for cathode. So I'll just go over it. Positive anode and negative is cathode. So that's an easy way to remember the charges of the two. Now, one thing also to remember, that things that go towards the anode must be the opposite charge. So the things that go towards the anode must be negative. And they will be anions. Because they're going toward anodes, they'll be anions because they've charged atoms, okay? Anions go towards anodes, they're the opposite charge, and if the anode is positive, they must be negative. Okay? So when I talk about anions, I'm generally going to be talking about, I say generally, I'm always going to be talking about non-metals. So I'll also write that there, non-metals. Negative is cathode, okay? Now, just like the anode, the things that go towards the cathode are going to be positive. And because they go towards the cathode, we call them cations. And these are generally metals, but occasionally they might be H+ ions or hydrogen ions, okay? So I'll just put metals there. Okay? So, just to help you remember, we've got that handy little kind of thing. Positive anode, negative is cathode. The things that go towards the anode are called anions, they will be negative. The things that go toward the cathode will be positive and they will be called cations, okay? That's a really useful way to kind of remember this. And it kind of just works out quite well because all of these are non-metals, all of these are anions because they're going towards the anode. All of these, however, will have been cations and they will have gone to the cathode. Now, I'll start off with copper, okay? I'll start off with copper. And you can see here, we've got copper here, sodium here. We've also got 2 chlorides and 2 sulfates. So the cations are the copper, the cations are the sodium, However, the anions are the chloride, the sulfate, the chloride and the sulfate. Okay? So, just starting off on the copper, the two copper. So we're going to look at this. The reason these went brown is because copper is positive. And the reason Sir has drawn 2 there is because it's 2 plus. Okay? So therefore, going towards the cathode is going to be the positive copper ions. Now, because the cathode's negative, the cathode contains a lot of electrons. And we formed a brown thing, which is copper. Now, you'll notice this. We've got copper, which is 2 plus 2 electrons to balance equals copper. Now, this is a higher tier, higher equation. So if you don't do higher tier, don't worry about this. It's generally considered higher tier. Okay? These are called half equations. Okay? Now, because it's the cathode, therefore there's going to be a large amount of electrons there. That's why it's negative, because it has electrons. Electricity transporting electrons around. Okay, now I'll look at the sodium. Now you would assume sodium is going to go towards the cathode because there are sodium ions in there. And that would make sense. However, now there are numerous reasons for this, but I'm only going to focus on one, okay? Since we know about reactivity series, sodium is towards the top, whereas copper is much way further down. And in fact, hydrogen is in the middle. We know water, these are all in solution, all in aqueous solution, so they're all in water. So if sodium's at the top, copper's at the bottom, hydrogen's in about there, okay? They will go towards the cathode. So sodium's towards the top with a full outer shell because it's more reactive. The hydrogen, which is much lower down in the reactivity series, goes towards the cathode. Therefore, at these we form hydrogen. And again, I'll show you the half equations for the higher tier. H plus ions plus an electron forms hydrogen. Now, hydrogen is diatomic. That means there is 2 hydrogens. So therefore, we will have to have 2 hydrogens here and 2 electrons there. Okay? Balancing half equations is easy marks to get in your exam. Okay? So at these two, we've got copper there and hydrogen there. Hydrogen's formed because hydrogen's lower reactivity. And some of you might be thinking, well, why is hydrogen not formed here? Well, as I've stated, copper's down here. Hydrogen's above copper in the reactivity series. So that's why copper, okay, is formed. It's also worth noting, and I quite like this thing, but we use electrolysis to produce hydrogen, okay, which is great. The sodium's left in solution with the hydroxide ion. So it actually ends up forming sodium hydroxide here, which is how we make bleach. And you can do it from brine solutions. Brine solutions means salt solutions or sodium chloride. Okay, now I'm going to look at the anode. Now the anode is positive and the anions go towards the anode, okay? Now, Sir tested to show that chlorine is formed there. Again, that makes sense. We've got chloride ion here, we've got a chloride ion there. Worth noting out, these are ides because they're ions. This is ene because it's a whole atom or a molecule, an element. Whereas these are ions. So the halides, the halogens turn into halides if they gain electrons. Okay? So again, just showing you a half equation. We've got chlorine, which is negative because it is negative anions. It goes towards the anode, which is positive, and it gives up its electrons. Remember, chlorine's diatomic, so you would need 2 of the chlorines, and clearly, therefore, 2 electrons. Okay? So now I've gone through the chloride solutions, so copper chloride and sodium chloride. I'm going to briefly mention the sulfate solutions. Now, again, there are multiple reasons for this, and I think this is I don't even think you need to know this, but it's all to do with the reactivity as well. There is hydroxide ions, just like there are H plus ions. Hydroxide ions, by the way, is OH minus. Okay? And H plus ions are H plus ions, or protons. So at this one, we form oxygen, and again, multiple reasons. But let's just mention reactivity again. You would assume it's because sulfate is higher up the reactivity. Oxygen forms there. And just like before, oxygen is 2- because it's in group 6. Going to the anode, it is diatomic, and therefore will give up its electrons. There are 2 oxygens with 2 electrons each, therefore there will be 4 electrons there. Now it's worth noting a few things here, okay? Firstly, at the cathode, electrons are on the left-hand side. Notice we've got positive here, negative here, which make neutral overall, and this side is neutral as well. The same for this one. The electrons are on the left-hand side, whereas at the other one, the anode, the electrons are on the right-hand side, and actually the left-hand side is all negative, and the right-hand side, due to the electrons, is also negative. And the cool thing about this is the electrons then go over to the cathode, because obviously the electrons are doing a circuit. That's why we have electricity. Another thing I've noticed on some questions is about this. This is a blue colour. It's only blue because of copper, nothing else. Therefore, if we're producing copper at the cathode, remember copper is a positive ion, so therefore it goes towards the cathode, which is negative, and you can see the copper colour there. Therefore, if we're producing copper here, the element is forming here. The ions are being taken out of solution. But copper ions are this lovely blue colour. So if they're being taken out of solution, this should get, if we leave it on long enough, less and less blue. Also worth noting that this inert one should get thicker and thicker due to the copper forming on it. Before I leave you, I just want to do one last thing, and it relates to these half equations. So I'm going to draw it over here. There's a good acronym to remember called oil rig. Oxidation is loss, reduction is gain. Therefore, these are gaining electrons. That's why the electrons on the left-hand side. These are undergoing reduction. However, these are losing electrons. Therefore, these are undergoing oxidation. Worth remembering these acronyms. Oxidation is loss, reduction is gain, oil rig, and panic, which is positive anode, negative is cathode. Okay? Thank you.